All right, ladies and gentlemen, welcome to our next part of this lesson about vector transformations with matrices. If you haven't done the notes yet and watched that notes video, go stop this, go get the notes and do the examples on there so you can kind of get a feel of what's going on with these vector transformations using matrices. So what's going on here is I'm going to do some examples from your assignment so you can have them as some help as you go through these. So on this first section, you're taking, on all of them, you're starting with the vector -7, 5, and you're timesing by whatever matrix is there. So let's do this one. We got -7, 5, which, again, you can change your brackets there and times it through like normal. Remember, it's the rows of your first matrix times the columns of the second. So we're going to do this row times this column, which will mean -7 times -1 and 5 times 0. So yeah, write this out. -7 times -1 plus 5 times 0. And then we got to do the second part. So this row times this column next. So it's -7 times 0 and 5 times -1. So -7 times 0 plus 5 times -1. And we're going to go ahead and simplify this matrix here. -7 times 1 is 7, 5 times 0 is 0, so we got 7 plus 1, which is 7, and then -7 times 0 is 0, and 5 times -1 is -5, and we're going to add those together to make -5. So now we got this matrix, which turns into this vector here. Well, you're also supposed to write down what the transformation is. So we started out with -7, 5. We ended up with 7, -5. Well, if you haven't done so yet, you should compare that with your notes. And you can also look at what this matrix does to vectors. And take a moment to do that and just say aloud, what happened? Did you say it? I can't tell. I can't really hear you. That's okay. If you said it out loud, good job. And if you also said that this was a 180-degree rotation, even more better, I guess, is the right term for that, I think. Anyway, this is a 180-degree rotation around the origin. So yeah, let's move on to another example. Alright, so let's go to number 2. At this point, if you follow along your notes and on this, you should have had 5 examples. Let's have you try this one out. You're starting with -7, 5, and multiply by this matrix to see, to get a new matrix. So pause the video and go ahead and do that. Alright, let's have you check and see. Did you get -5, -7? If you did, you should give yourself a pat on the back. You know, maybe go give yourself a little treat, because that's exactly what you should have gotten. And now we need to figure out what transformation this is. What made the vector go from -7, 5 to -5, -7? So go ahead and look at your note paper, and actually I copied and pasted it in here. And let's see, look at this function and see what would take our two components and change the order. And the 5 used to be positive, but that ended up negative. So it changed the order, and it changed the sign on the first one. So look through your functions here and see what transformation does that. If you're able to find out that it's this one here, and you can notice that it's a 90-degree counterclockwise rotation. You can also compare it with the matrix. Is this the matrix we multiply by? Yes, and so this is a 90-degree counterclockwise rotation. Ta-da! Alright, let's go ahead and do some more. On this next section, you just need to transform it. And so we're going to take this vector and multiply by this matrix. And this one's got some 4s in it, but that doesn't really change the process. You're still going to pretend this is a matrix, get rid of the comma, and it's going to be this row times the column, and then this row times the column. You'll add them up. So go ahead and multiply this vector by the matrix and see what happens. Pause the video. Alright, let's see how you did. Did you get 36, 12? If you didn't, kind of double check and see how things went. You might have messed up the signs here. -3, -4 times together gives you +12. But yeah, let's go ahead and see what transformation or transformations happened here. So we had our vector here, 9, -3, ended up with 36, 12. So basically, both of these numbers got times by 4. And you should have seen that in the matrix here. We got 4 and a 4. Well, these are going to be 4 times as big. So this did have a dilation by a factor of 4. Factor of 4. And that's not the only thing that happened, because 9 times 4 gives you 36, but -3 times 4 doesn't give you 12. You have to do -3 times -4, which was right here. Which means there was a sign change on the y value. So let's look at your notes and again figure out which transformation has a sign change on the y value, and that's the only change. Well, that's going to be this one, which is reflecting over the x-axis, which is this matrix. So yeah, we had this matrix, but it's all times by 4, right? We had 4 here, and then -4 here. So this has dilation and, and it reflected over the x-axis. X-axis. So it's got both. This section doesn't tell you to write down the transformation, but I wanted to write it down so you could see it and realize you can dilate and do one of your rotations or reflections as well. So we got 2 more examples for you. This one's going to be a little bit different because you're not just taking vector and times in by a matrix. Instead, on 13, you need to figure out what matrix is going to make this happen. So look at what you have. We got 2, 8, and then -8, 2. Well, it looks like we got a change in order here, right? It was 2, 8, now it's 8, 2. So we got a change in order. Well, there's also a sign change, right? 2 went to 2, but 8 went to -8. And so, once again, look at your note paper and kind of figure out what transformation switches the order and then changes the sign on the new first one. Go ahead and point at it. Go ahead, make a guess. You can pause the video if you want. Do it. Hopefully you picked this one, which is a 90-degree counterclockwise rotation. Well, if we are looking for the matrix that does that, which is what our goal is, you can actually look at your note paper and be like, oh yeah, that is the matrix that does a 90-degree counterclockwise rotation. And so that is the one you can write down. So you got 0 and 0, and then 1 and -1, and da-da-da-da, you got the matrix that'll do that transformation for you. And if you're unsure if you're right, you can always just take your vector, times it in, and see if you get the resulting one. Alright, and we're going to do one more. I wanted to do this one because I get a lot of people who ask about it, and I figured I'll do it now, so people don't have to ask about it later. This one, you got 3 and 9, and then you got 27, -9, which it's kind of looking like 9 got a sign change, but 3 got times by something. Unfortunately, that is not one of our transformations that we're dealing with. You could do a horizontal stretch and then reflect over the x-axis, but let's just keep it to dilations and rotations and reflections for now. And so this isn't going to be just timesing one number by 3. Instead, if we times both by 3, you'll get 9, 27. Ooh. And then you may notice there's a switch in the order, right? We got 27 and then 9, and that 9 got a sign change. So it's looking like we got x, y, that both got times by 3, and they got reversed and a sign change. So we're looking at 3y, 3x, and there was a sign change on the new x component there. And so this does have a dilation by a factor of 3, and it is rotating 90 degrees clockwise. And the way I can tell that is by looking at here, right? What switches the order and changes the sign on the new second one. Sorry, that's 90 degrees clockwise. And so our matrix is going to look like this, and you have to dilate by a factor of 3. So you're going to take this and times by 3 to get your matrix you're looking for, which Let's go ahead and write that out. 0, 0, 3, negative 3, and voila, that's what you're looking at. At least hopefully I wrote that down right. Where's my notes? Yeah. 90 degree. Yes, just like that. Sorry, I was double checking myself. And there you go. Good luck out there. Stay safe. Stay home.